Hey y'all, it's Mr. Thibodeau. Just going to go over our last assignment of the week, or our last math anyway, adding, subtracting decimal numbers and whole numbers, and then to, make it a little difficult, squares and square roots, okay? First part's not so difficult. Second part might be. All right, do your mental math, do your problem solving, new concepts. Margin sales sign. What is another way to write the $3? So $3 each. So $3, or you could write 3.00, no sense. Okay. 3 point, 3.0, 3.00, all the exact same number. And in fact, there's even more ways to write it, right? I could write 3 over 1, same deal. Shoot, I could write 6 over 2, also the same deal. Okay. There's a lot of ways to write this. I could write 03.00 if I wanted to. I probably don't want to. I can't imagine how it helps me, but I could. Okay, lots of ways to write the same number. Over here, this is what we did last week, right? Or yesterday. Subtract 12.75 from 5. I don't think that's much different than what we've done. Same sort of deal. Now here is where things start to get a little different, right? Now we're suddenly going to start talking about square roots. Recall that we find the area of a square by multiplying the length of a side and the square of the square by itself. For example, the square area of a square with 5 centimeters by 5 centimeters is 25, 5 times 5. From the model of the square comes the expression squaring a number. Okay. To indicate squaring, we use the exponent 2. Okay. So anytime we're using an exponent, okay, it is telling us, so you know how like 5 plus 5 is can be simplified by writing 5 times 2, right? That means we're adding, multiplication is just adding faster, right? 5 plus 5 plus 5 plus 5 would be 5 times 5, okay? Multiplication just tells us how many times we're adding something. Now, exponents are telling us how many times we're multiplying something. So it's just multiplication faster. So when I do 5 squared, okay, it's just telling me that I am multiplying 5 by 5 2 times. So that turns into 5 times 5, okay, which in itself is just 5 plus 5 plus 5 plus 5 plus 5, okay. So an exponent shows how many times the other number, the base, is to be used as a factor, okay? So 5 is going to be used as a factor twice. You're going to multiply 5 by 5 twice. If I had 4 squared, that would turn into 4 times 4. You can actually see all of these, and the reason why we call them square roots is you can see each of the square roots right here. Okay, so 1 times 1 is 1. 2 times 2 is 4 squares. 3 times 3 is 9 squares. 4 times 4 is 16 squares. And 5 times 5 is, let's get that right. 5 times 5 is 25 squares, right? So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I could add up 5, 5, 5, 5, and 5, and I'd get 25. I could take 5 and multiply it by 5, and I could get 25. Okay, this is why they're called square roots. Okay? It increases each time pretty drastically. Okay. What is 12 squared? That would be 12 times 12. Okay. Which is what, 124, something like that. Simplify 3 squared plus 4 squared. 3 squared plus 4 squared. 9 plus 16 equals 25. Fun fact, this is actually one of the perfect squares set for the Pythagorean theorem. But that's a whole different deal. We'll get into that way later. All right, they talk more about that square theory that I was showing you here. They talk a little bit about squared roots, which I think they really go from 0 to 100 here. Squared roots is the opposite. So if an exponent is showing you how fast you're multiplying, the squared root undoes that. It's difficult math to do. We use a calculator usually for it, or we memorize. Mostly we memorize the squares. It's pretty easy to memorize the first 12 or so perfect squares, okay? Because 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. You know, we already really know these numbers because we've done them. They're part of our multiplication tables. 9 times 9 is 81. So a lot of these we've already memorized, and so it's not too difficult. However, when you get into, say, like the square root of 15, that's a whole different deal. The good news is you won't have to actually try and solve that for a very long time, if ever. Okay. So I think, oh wow, they do some really weird stuff here. When you get to things like this, just know that you reduce first. 10 minus 7 is what this is, okay? 144, you gotta figure that one out. Oh, that's what that was. Pretty sure. All right. Let's see. I think you should be able to get all of these. Yeah, so I think you should be okay. If you have any questions with this stuff, please feel free to ask. It's definitely, this is the most complicated chapter that you've done this week. So for your work, let's go ahead and we'll do 4 through 9, and then we'll do let's do 14 through 27. Okay, I think that should be it. All right, guys, have a good one.